So in this lecture, I will teach you how to deal with the double integration limit. Okay. Now we can have a limit in terms of some constant. Okay. So firstly, this double integration is denoted by double integration value with the sum function f of x comma y dx dy, where this f of x comma y is equal to 1, then this integration is called area. Okay, area. Now uh, we have to come on this limit values f of x comma y dx dy. So the so this limit can be x is equal to a, y is equal to b, some x1 is equal to c, and y1 is equal to d. Okay, like I take a symbol I, x is equal to start with the a, x1 is equal to c, and y will be start with the b, some y1 is equal to d with some function f of x comma y dx dy. So this type of limit is called constant limit. Okay, constant limit. And second, if some x is equal to f of y and x1 is equal to some g of y and y is equal to a and y1 is equal to some b, then this I will be represented with y is equal to a to b and x is equal to f of y to g of y with the function f of x comma y dx dy, and this is called vertical limit. Okay, then third we have x is equal to some constant a and x1 is equal to some b and y with some f of x and y1 with some g of x value, then this I will be represented with firstly y is equal to fx to g of x and x is equal to a to b f of x comma y dy dx. This is called horizontal limit. Okay, horizontal limit. Now, what is the cause of taking horizontal limit? If I take a simple curve this way, okay, and here is a curve, graph, okay. If I take a limit this one, this limit, which is parallel to x-axis, so my this curve to this curve. So this is called x is equal to f of y, okay, and this curve is called x1 is equal to g of y. In that case, our y will be constant, and this limit is called vertical strip method. Okay. Similarly, we can also find a limit this way, parallel to y-axis. Okay. Now this curve y is equal to f of x, and this curve y1 is equal to 0 x, and x will be a to x1 is equal to b. So this type of limit is called horizontal gentle strip method. Okay, strip method. And first, when we have a simple line equation this way, so then there is a x is equal to 1 and x1 is equal to b and y is equal to c2, y1 is equal to d limit, constant limit. Okay, now, so how to solve this limit? Okay, now how to solve this limit in double integration? Just take a simple problem. Evaluate x is equal to 0 to 1 and y is equal to some 0 to t 2, and there will be a function I can take x into y dy dx. In this case, when the limit is constant, we can solve either dy limit first, then dx, or we can solve first dx, then dy. Like I assume that I is equal to x is equal to 0 to 1 and y is equal to 0 to 2 xy integration with respect to dy and dx. So firstly I will solve this limit is equal to 0 to 2 this way, x into y dy, and then I will solve with the dx. Okay, this means that firstly we have to solve this limit 0 to 1 and y is equal to 0 to 2 xy with respect to dy and dx. When we are solving this y limit, then x is constant. Okay, so if x is constant, all of you know that what is the integration of y is a y square by 2. So x constant, so we can take outside and then we will solve y is equal to 0 to 2 and here y dy and then dx. And we know that x to the power n dn limit is x to the power n plus 1 divided by n plus 1. So by solving this, we will do x is equal to 0 to 1 x. By using this formula, we will find the limit y square by 2, and then after that, we will put the limit 0 to 2 dx. By putting the limit, we will get to upper limit minus lower limit. So x, and this will be 4 by 2 minus 0 by 2. Okay, upper limit is 2, so 2 ka whole square is 4 by 2 minus lower limit is 0, so 0 by 2 with dx. So what we will get is equal to 0 to 1 x 4 by 2, so this will be 2 and dx. Okay, so this is equal to, we can take common 2 and we have to solve x is equal 0 to 1 x dx. Okay, so this again by when solving x to the power n, this limit integration is x square by 2 with the limit 0 to 1. So 2 to cancel out, upper limit is 1 or lower limit is 0, so answer is 1. Okay, this is the first method. We can solve with first with the y and then x. Then there is a second method and you will get the same answer by putting first y is equal to 0 to 2 and then x is equal to 0 to 1. In this case, xy dx and then dy. So in case of constant, we can simply interchange the limit and we will get the same integration value. In this case, firstly we have to solve y is equal to 0 to 2 and then x is equal to 0 to 1 x dx and y is a constant, so we are taking the outside of the integration. Okay, so now this I is equal to y is equal to 0 to 2 and then y which is outside or x ka integration is x square by 2 and it will be limit value is 0 to 1 dy. So 1 by 2 we are taking outside because it's a constant 0 to 2 y and this limit is 1 minus 0 dy. Okay, just 1 by 2 y is equal to 0 to 2 and here we have y dy. Okay, now solve this y integration which is y square by 2 and 0 to 2. So 1 by 2 again 1 by 2 is so it will be 1 by 4 and by putting the limit value we will get 4 minus 0. So answer is 1 by 4 into 4 which is 1. So you can see that easily by so in case of rectangle this a to b limit x is equal to a to b and y is equal to c to d f of x comma y dy dx is equal to y is equal to c to d x is equal to a to b f of x comma y dx dy. Okay, so this is the only case because here we are having the constant value. So either you can solve first y or you can solve first x, the limit value will be same. Okay, I, you will understand. So I will give you a question for the practice. You just try evaluate integration limit x is equal to 0 to 1 by 2 y is equal to 0 to 1 by 4 with the function x plus y dy dx. Try to solve. Okay, now the second type